My name's Todd Bridges, and I'm the Army's Senior Research Scientist for Environmental Science, and I also lead our Engineering with Nature program within the U.S. Army Corps of Engineers. And today I'm going to talk to you about engineering with nature for comprehensive water resilience. The natural hazards that we confront in the country today and the complexity introduced by climate change is presenting a very significant challenge for our communities and for those organizations at the state, local, and at the federal level that develop infrastructure solutions related to water. We can look at a whole variety across the United States of challenges and hazards that we confront, from extreme heat to extreme rainfall, coastal storms, water stress, drought, aridification. If we look at the traditional dividing line between the humid east and the arid west, the 100th meridian, there's evidence established in the literature to show that line of demarcation is actually moving east, posing very significant challenges to our country, and particularly for the western part of the country, which is now experiencing a 20-plus year drought that is more intense than any experienced in 1,200 years. We also have to reconcile in our own minds and in our approaches widely varying extremes. I had a personal experience in this regard recently. I spent a day in Death Valley at the end of July 30th, went to Mesquite Flat sand dunes, and at 7:30 in the morning it was 98 degrees Fahrenheit. It was an interesting day to view such a unique landscape. But then 6 days later, after we left Death Valley, 6 days later, Death Valley had experienced what is described as a 1,000-year rain event, in which in one day they received 75% of their average annual rainfall. And it created devastation across the entire valley, trapped 1,000 residents and visitors to the park with debris flows, closed all the roads in the park. So at the same time that the West is experiencing a drought, it can also experience flooding. And we need to be able to reconcile that, if you will, paradox in our thinking, and also in regards to our strategies as they are expressed in the form of our infrastructure solutions. The hazards we face across the country take a variety of forms, and they produce a whole range of impacts, from loss of life to economic damages, and also damages to national security. High water and flooding in 2019 along the Missouri River and other rivers in the Midwest produced a whole range of damages, including, in this particular case, nearly $1 billion in damage at Offutt Air Force Base outside of Omaha, Nebraska. So as we consider our approaches to rehabilitating as well as developing new infrastructure solutions in the future, how do we develop those systems to address present and future challenges? One of the approaches that we will take in the 21st century to develop more comprehensive and more resilient infrastructure systems is by using nature-based solutions. This past spring, the President issued a new executive order titled Strengthening the Nation's Forests, Communities, and Local Economies, Executive Order 14072. And Section 4 of that executive order is titled Deploying Nature-Based Solutions to Tackle Climate Change and Enhance Resilience. And it includes, this section, commitments in three forms: to produce an interagency report on accelerating delivery of nature-based solutions across the country, a commitment to develop guidance on valuing nature to be used as a part of our decision-making at the federal level, and third, a commitment to produce the first ever National Nature Assessment, modeled after the National Climate Assessment, but an assessment that is focused on nature, its status, and the value that it produces for our society. There are a range of definitions for nature-based solutions in the literature, but most of them include this fundamental core definition of conserving, restoring, and engineering nature for the benefit of people and nature. Nature-based solutions, otherwise known as natural infrastructure, can take a whole variety of forms, including an island wetland complex that attenuates storm surge in regard to coastal storm risk management, or a restored inland floodplain that reduces risk from inland flooding by providing space for high flows, surface heat reduction through the creation of green space and forest restoration, drought and wildfire resilience through restoring native vegetation, water resilience through constructed freshwater wetlands that can absorb excess nutrients and at the same time recharge depleted groundwater aquifers, or even in regards to climate change mitigation, restoring native grasslands and other plant communities along our rivers and coasts and landscapes to sequester carbon in soil. The history and development of the concepts and the ideas and the capabilities and tools for what today we call nature-based solutions is actually a long one, dating back decades in time. Just 2 points I'll make here, going back to the development of what today we call ecological engineering and H.T. Odum and his students, the ideas that they framed on how to make use of natural systems in the context of engineering, such as through the use of treatment wetlands. And we could look at the development of very similar and comparable ideas in the context of urban planning and landscape architecture. With the publication of Ian McHarg's seminal work, Design with Nature, in 1969, he was drawing from similar approaches to leverage natural systems to integrate them within human systems to produce what today we would call more sustainable outcomes and more enriching places. In 2010, we started an initiative, a program within the Army Corps of Engineers that we call Engineering with Nature. The definition is provided here. We're looking for ways in which we can more intentionally align natural systems and engineering processes to deliver a range of benefits, economic, environmental, and social benefits through collaboration. And we emphasize 4 main elements here: using science and engineering to produce operational efficiency, using natural processes to maximum benefit, increasing and diversifying the value that can be produced by such integrated infrastructure, and using science-based collaboration. And it's a whole range of activities we've undertaken over the last 12 years, including research and development and application and communication activities and initiatives, as well as a whole range of partnering across sectors to produce, in essence, approaches for delivering nature-based solutions. It's important to make the point that the progress that has been achieved in the last decade in developing and fielding nature-based solutions is significantly due to advances in the science supporting nature-based solutions. And really there are multiple lines of evidence, multiple lines of science, if you will, that are supporting the development of these approaches, including physical modeling, such as of mangrove physical systems and how they attenuate waves, the advancements that are being made in numerical modeling that capture the processes represented by nature-based solutions, the study of natural analogs, such as how wetlands responded to Hurricane Michael on the panhandle of Florida, scale demonstrations of these techniques across the country as well as around the world, and experience that is continuing to grow, project monitoring at constructed projects, the use of and access to traditional ecological knowledge, as well as the application of engineering judgment in the use of these approaches. I could highlight many examples that have been developed and published in the literature documenting the value that can be produced through nature-based solutions, including this one here, where coral reefs and the importance of coral reefs around the world in respect to coastal storm risk management, and how science and modeling have been used to reveal literally the billions of dollars in avoided flood damages that can be attributed to coral reefs around the world. The Defense Advanced Research Projects Agency, or DARPA, has in fact started a new program called Reef Fence, in which they are investing more than $50 million to advance engineering development, bringing human engineering in combination with coral and oyster reefs to develop systems that can provide coastal resilience relevant to military installations in the context of the DARPA program, but also relevant to communities around the country and world. If you're interested in this topic of nature-based solutions and their relevance toward water, I can recommend Erica Giese's book, Water Always Wins, Thriving in an Age of Drought and Deluge, in which she highlights the relevance of nature-based solutions in a whole variety of contexts around the world and, in fact, over time, and what she calls the slow water movement. How is it that we can slow down the movement of water across landscapes occupied by nature and by people, and thereby derive benefit in terms of flood risk reduction, but also in terms of conservation and the development of nature, the recharge of groundwater, hydrating our landscapes, making them less susceptible to drought and heat and wildfire. A very significant, large amount of investment is being directed toward these kinds of solutions, natural infrastructure. In the passage of the Infrastructure Investment and Jobs Act in 2021, I did my own word search on the term natural infrastructure in that law. And in fact, that term is used 17 times in that bill that invests more than $1 trillion in infrastructure across the country. And you can see a breakdown here across a number of agencies. Literally billions of dollars are being invested through this law in natural infrastructure. Engineering with Nature, the program, is currently involved in supporting organizations around the country and identifying ways in which those communities, those organizations can use nature-based solutions to satisfy their goals and objectives. And we've given some thought to, the method for accomplishing this. There's nothing particularly magical about this, but this slide lays out a simple progression of thought and activity in this regard, that we need to gauge an installation or a community's vulnerabilities, needs, and opportunities with respect to infrastructure and nature and human systems. Second, identify ideas and ways that nature investment could actually support comprehensive resilience. And then conceptualizing nature-based interventions in the form of specific actions or projects that could be developed in ways that are consistent with that view. Then evaluating those nature-based solutions for an array of relevant benefits using science and models and tools to accomplish that. And then developing the partnership community that would be used to fuel incrementally and at full scale implementation of those projects and interventions. Then phasing that demonstration and implementation over time, and then measuring and widely communicating the progress to build momentum. This is the soup to nuts approach to developing nature-based solutions for communities across the country. In wrapping up my talk, I want to identify the Network for Engineering with Nature, which we established just a couple of years ago as a place, a gathering place, if you will, where organizations across the spectrum, cross sectors could come together to advance engineering with nature, nature-based solutions through research and development and application as well as education. If you're interested in the network, I would invite you to visit the website and to contact us. Finally, I'd like to say that the challenge, need, and opportunity of the 21st century is to develop comprehensive resilience for our communities. And I've represented community here as a triangle. It's built assets, the things we construct, what we're accustomed to seeing built as infrastructure. It's people, but built assets and people, they reside on a foundation, a very important foundation of landscapes and ecosystems and nature. And this is where engineering with nature is trying to focus our attention through the development and use of nature-based solutions.